For 10th grade, the first chapter is about real numbers. Okay, so this is more or less sort of revision of what you have learned in younger classes and a little more theorems and lemmas coming. Let me ask you an example. Here I have 2010. I want to divide 2010 by 20. Okay, so when I want 2010 by 20, divide by 20, this 2010 is called dividend. Okay, and 20 is called divisor. Fine. Now you're going to divide 2010 by 20. How many times it will go? 20, it will go one time. 20, bring down 1. 1 is smaller than 20. It will not go, so bring a 0. It will be 0. You have 1 remainder. Bring down the next 10. 10 is again smaller than 20. So you have got 100 and again it's 0. So remainder is 10. Okay, I'm not going with the decimal point part. So here, when I divide, I am getting 100 as quotient. Okay, quotient is 100. 10, this 10 that I get, that is called remainder. Okay, so you need to know what is a dividend, what is a divisor, what is a quotient, and what is remainder to understand Euclid's division lemma. Okay, so we are going to talk about Euclid's division lemma now. But before that, please understand when you have a number and when you are dividing that number by a divisor, you get a quotient and sometimes you get a remainder. You don't need to, it's not mandatory that you should have a remainder. Sometimes you get 0 as the remainder. Sometimes you get some number which is greater than 0 as the remainder. So we have something called Euclid's division lemma. So what is Euclid's division lemma saying is dividend is equal to divisor into quotient plus remainder. Take the example, 2010 is equal to, what was the divisor? 20 was the divisor. 20 into, what is our quotient? Our quotient is 100. Yes, so 100 plus remainder. What is the remainder? Remainder is 10. So are we getting to 2010? We are, right? So that's it. So this is what Euclid's division lemma talks about. And we need to know what is proper definition. See, the idea is this, which you have learned in probably 6th grade or 5th grade, you have learned it, right? So how do you write it in a more technical or mathematical way? That is, for any two, I'll just note it down. I want you also to write along with me. For any two given positive integers, for any two given positive integers a and b, there exists unique whole numbers q and r such that a is equal to bq plus r, where r, okay, r is lying between 0 less than or equal to r less than b. This definition for any two given positive integers. What are the positive integers? A and b. Okay, positive integers are a and b. There exist unique whole numbers. So what this means is when you divide a by b, okay, there exists a unique whole number. So when you divide a number, when you divide a dividend by a divisor, you get a whole number. as quotient, right? You get a whole number as quotient. Is that unique? When you divide 200 by 2, are you getting different numbers in quotient or you get only one number? 200 divided by 2, is it always 100 or each time different number will come?
It is always 100.
It's always 100. It's always 100. That is the reason why they are saying unique. Unique means only one value. Whenever you divide, it will get only one value. That is unique. Okay, so when you divide A by B, you get unique whole numbers. And maybe some steps are coming, and remainder is denoted by R, right? You see there exist unique whole numbers Q and R such that how will remainder be? Is it mandatory that always there should be a remainder? In this case, in this example, 200 divided by 2. Do you get a remainder here? When you divide, what do you get? You get a remainder 0, right? You don't have any other value. So your remainder will vary from 0 to vary between 0 and 1. Can you get 2 as remainder? Is it possible? Will you get 2 as remainder in this case?
No, ma'am.
You can never get 2 as remainder, right? So the only values that you can get is 0 or 1. That means what is the divisor? Look at the divisor. Divisor is 2. So the values that it can have is less than 2. 0, starting from 0 to less than 2. In this case, less than the divisor. So I hope this definition is clear. For any two given positive integers A and B, there exist unique whole numbers Q and R. Q is the quotient, R is the remainder, such that A equal to BQ plus R. See, A equal to BQ plus R, I have already told you, this is the dividend, this B is the divisor, and what is Q? Q is the quotient and R is the remainder. So a number when divided by 73, a number when divided by 73, that means, do you know the number? You don't know the number, right? So take that number as X. So let the number be X, because you don't know what is that number. A number when divided by 73 gives 34 as quotient. So divisor is 73. Quotient is QUO. Quotient. Quotient is 34. And what is the remainder? Remainder is 23. Okay, find the number. This is the question. Very direct, right? It is direct substitution. So what you just need to do is dividend equal to divisor into quotient plus remainder. Just put the values, that is equal to X equal to, you can write that 73 into 34 plus 23.
2505.
2505. Yes, this is our number. What is meant by a lemma? I told you there is this. So you have a already proven statement with you, something which is already proven. Use that statement to prove something else. Got it? That's called a lemma. So you can get it as a multiple choice question. You have a proven statement. Use the proven statement to solve a problem. Okay. So a lemma is a proven statement used for proving another statement. Okay. Now let's discuss about Euclid's division algorithm. Euclid's division algorithm is using Euclid's division lemma. So Euclid's division lemma is nothing but dividend is equal to divisor into quotient plus remainder, where remainder will be a number between 0 and 0 less than or equal to, remainder less than the divisor, right? So this is our Euclid's division lemma. Now use this division lemma to prove certain things. Do you remember finding HCF using long division method or division method? Finding HCF, I'm just giving an example here. Finding HCF, there are different ways to calculate HCF. Prime factorization method, then division method. So finding HCF by division method. Finding HCF by division method is actually the Euclid's division algorithm. HCF by division method is, the new name is Euclid's division algorithm. Find HCF of 272 and 1032. This is the question. Find HCF using Euclid's division algorithm, and every year it comes in the board. Euclid's division algorithm. So division method is check which is the bigger number. You have two numbers, 272 and 1032. Which is bigger number among that? Tell me.
32.
1000.
Yes, 1032 is a bigger number. So now 1032 you're trying to divide by 272. Only this is first step. You have 1032. Because 1032 is a bigger number. Try to divide 1032 by the smaller numbers.
816.
860. Okay, fine. Yeah. Now do the subtraction. See, normal division you are doing, instead of putting the quotient here, you are putting the quotient on the right hand side. Okay, you are not putting the quotient on top. Instead, you are putting right side of that box. It is going to be 216. Okay, 216. Now what? 116 is the remainder, right? What should I do now? I need to do 216 is the remainder for this operation. Keep it there and bring our divisor here. Okay, so now write 272 inside like this. Now you're going to divide by 272. Okay, what was your previous divisor? That becomes the dividend in the next step. Previous divisor become the dividend. And your remainder becomes the new divisor. Okay, so this is what it talks about. So how many times it will go? It's very simple, right? It just goes one time. Yes, so 216 and 272 only one time. So you have got 216. So find the remainder. What is the answer that you are getting?
46.
46 or 56?
56.
56, right? Yes.
Oh, yeah,
So
56.
yes, 56. So this is the new remainder. Again, I told you, remainder will become the divisor and your previous divisor will become the new dividend. So 216 will become here, will come and sit as the dividend. Okay. How many times 216 will go in 56?
Thrice.
Thrice. Okay. What is the value? Can you 3 into 56? What would be that?
168.
168. Okay. 168. Now subtract. Again, when you subtract, what do you get?
You get 48, I think.
It is 48. Yes. Previous divisor becomes the current dividend and the remainder becomes the divisor. So here it will go only one time, 48, and you have got 8. And again, this 48 will become your this thing, new dividend. How many times 48 will go in 8?
6 times.
6 times. Now this time, what is our remainder?
0.
0, right?
0.
So now what is HCF? HCF is the last divisor. Last divisor is the HCF. So this is what you have learned in your younger classes. So the process of finding HCF using a division method is what is explained in Euclid's division algorithm. Okay. So what happens here? Take the bigger number. When they are giving you two numbers, take the bigger number, divide it by the smaller number. Remainder becomes the divisor in the next step. And the divisor of the previous step becomes the new dividend. Continue this process till the remainder becomes 0. So what is meant by algorithm? If those who have learned computer, they will know what is an algorithm, right? Algorithm is some well-defined step. Say, for example, like take water, boiled water, then when it boils, put the tea leaf. All these are steps. Turn off the gas. So these are all steps. So well-defined steps to perform a task or perform a action. That's called algorithm. What is an algorithm? It's a series of well-defined steps which gives a method for solving a certain type of problem. And here in my example, what was the problem? Problem was making a tea, making a cup of tea. That was the problem. So first step is on dividing A by B, we get a quotient Q and remainder R such that A equal to BQ plus R, where 0 less than or equal to R less than B. Okay. Now, what is step number 2? Step number 2 is saying that if R equal to 0, if when you divide A divided by B, you got some value, okay, some quotient is coming here, but on subtracting, you are getting a 0 here. Assume that the remainder is 0. If the remainder is 0, do you need to continue doing this? We can stop the process, right? So that's what they're saying. If remainder is 0, what is HCF of A comma B? What will be HCF of A comma B? It is going to be B. What is the last divisor? That is going to be your HCF. Okay, in the first step itself, if your remainder has turned 0, then the divisor is going to be B. I mean, HCF is going to be B. Got it? Now, if it was not 0, it was some other number, okay, then you cannot stop here. You have not found the HCF. Now, in this step, your remainder becomes the divisor and your previous divisor becomes the dividend. Are you getting this? That's all. So that's what they're saying. Continue the process. Okay, if R is not equal to 0, then apply the division lemma to B and R. See, division lemma where you should apply on B and R. So B and R means there they have changed. Earlier it was A and B. Now it has become B and R. When you say B and R, immediately you should understand B becomes dividend and R becomes divisor. Got it? Now continue this process until the remainder becomes 0. That's it. Okay, calculating HCF using Euclid's division lemma is a division algorithm is important. Use Euclid's division algorithm to find HCF of 1651 and 1651 and 2032. Express the HCF in the form 1651m plus 2032m. Need to find the HCF. Which is the bigger number? Is it 1651 or 2032? Which is bigger number? Pick up that. So bigger number is 2032. Divide it by 1651. How many times it will go? One time. Got it? It will go only one time. So the answer is answered. So you get 1651. Subtract, right? Remainder is 381. So you have a remainder. So we need to write some steps. First step, okay? Step 1 would be, since 2032 is greater than 1651, divide 2032 by 1651. We get Q equal to, Q equal to 1 and R equal to 381. Then by Euclid's division lemma, maybe you can write full form, Euclid's division lemma, you write what is this? 232 is equal to 1651 into 1 plus 381. Go to the next step. So we have a remainder, that is 381. Go ahead and divide our previous divisor becomes current dividend. So how many times 381 will go in 1651? It will go probably 3-4 times. Just try it. It will go 4 times, I believe, right? How many
Yes,
times?
ma'am, 4 times.
Yeah, 4 times. And can you tell me the value that you're getting? 1524. Okay,
Yes,
so
ma'am.
1524. Fine. So now when you subtract, you get
127.
127. Okay, so this is our step 2. Now we have to write about step 2 now. Okay, so write it as and when you get, when you do each step. So write it as step, this is first one. Our previous Euclid division lemma was step 1. Now step 2 is, what do you do here? Since R equal to 381, you will do, what is it? We have to proceed with divide 1651 by 381. We get Q, that is quotient, is 4, and quotient is 4 and remainder is 127. Again, we will write therefore by Euclid's division lemma, we have what? 1651 is equal to, which is the dividend. That's what you are writing. Okay. So in the next step, dividend has become 1651. So 1651 is equal to divisor, which is 381. Divisor into 4 plus 127, which is equation 2. 127 not equal to 0. So I have to again divide. Divide with what? 381. So roughly how many? So 381 is divided with 127. Step 3 is, since R equal to, what was R? R equal to 127, divide 381 by 127. We get Q equal to, what was Q? 3. Q equal to 3 and R equal to 0. Since the remainder is 0 here. When you divide 381 by 127, you are getting a remainder 0. So here we get Q equal to 3 and R equal to 0. Therefore, by Euclid's division lemma, (381) is equal to 127 into 3 plus 0, because remainder is 0. This is equation 3. Okay. So now, so R equal to 0, that means what will be our HCF? So HCF of the given two numbers. What are given two numbers? 2032 and 1651 is, which is the last divisor that gave 0 as the remainder. That is 127. So that is 127. So we found HCF now. What is the next step? So in the question, they have given express HCF in the form of 1651m plus 2032n. So you have to express 127. 127 is the HCF. So express 127 in terms of 1651m plus 2032n. Okay, so this is what you have to find out. So what is it that you need to find out? What is the value of m and what is the value of n? That is the next step. So how do you write? So HCF is 127. Just go up, look at the equation 2. In equation 2, you can see 1651 is equal to 381 into 4 plus 127. Okay, so keep 127 on one side and move this to the other side. So what are you getting? 127 is equal to, so here you can write 127 is equal to 1651 minus 381 into 4. Okay, so this is what you get. So here again, you don't need 381 in your final answer. How your final answer should look like? It should have only 1651 and 2032. 381 shouldn't be there. So the next step is look for how can you express 381. Okay, so it will be 1651 minus, how can you write 381? Look here in the equation number 1. Equation 1, you can see 381 as the remainder. Okay, in equation 1, 381 is the remainder. So take 1651 into 1 to the left-hand side, leaving 381 alone. Okay, so what do you get finally? 2032 minus 1651 into 4 into 4. From where I am getting? So 381 is what I have written like this. So 381 becomes 2032 minus 1651 into 4. Okay, so into 4, that is the last into 4 will come at the end. Okay, now you have everything in terms of 127, you are expressing in terms of 1651 and 2032. Let's expand it and see. So what do I get? 1651 minus 2032 into 4. This 4 I am multiplying to each and every terms. Minus and minus will become plus 1651 into 4. Okay, so next step is 1651, taking out common, I get 1 plus 4. Okay, so this is the first term, this is the second term. If I take 1651 out, I'm left with 1 plus 4 minus 2032 into 4. That can be written as 1651 into 5 minus 2032 into 4. Okay, so now don't you think I have got the answer? I have got HCF. HCF is 127. I am writing 127 in terms of 1651 and 2032. See here, take my equation is 1651 m. So I am equating see, I'm talking about 1651 m. I am equating it to 1651 into 5. So what is the value of m here? M becomes 5. Okay. Now the second part is 2032n. Here, look at this, plus 2032n. Now, plus 2032m, I am equating with, I am having negative 2000. Okay, negative 2032 into 4. So, what is the value of n then? I'm getting n as negative 4. So, now I have calculated the value of m and n. M becomes 5 and n becomes negative 4. Remember, you have to write n as negative 4 because in the given expression, 2032, in front of 2032n, the sign was positive. Here, the sign was a positive number. 2032 was a positive number. But when we did the process, we could express 127 as 1651 into 5 minus 2032 into 4. Okay, so because of that, 2032. You have to take it and write minus 2032 into negative 2032 into 4 and equate n to negative 4. Using the Euclid's division algorithm, find the HCF of 504, 735, and 84. So 3 numbers I am giving you. Take any 2 numbers. Say I'm taking these 2. Find the HCF of those 2 numbers first. Take 2 numbers, find the HCF. Maybe we can quickly do it. 504, which is bigger among 504 and 735? 704. Yes. How many times it will go? 1 time. So write 504. What do you get? 231. Right. Now, 231 is not equal to 0. So again, divide it by the previous divisor. Okay. So when you divide it by previous divisor, check how many times 231 will go in 504. So
Twice, Mama.
twice, right?
462. Yes, ma'am.
462. Yes. So 2 times. So again, what is the remainder?
42.
Yes, 42. Now 42, you are going to divide it by 231. 231. You are dividing it by 231 divided by 42. What do you get? 5 times it is going. So what do you get here?
210.
210, is it?
Yes, ma'am. So the remainder will be 21.
1 and 21. Okay. 42 divided by 21, not 21 divided by 42. So 42 becomes your new divisor, dividend. Divided by 21, it will go 2 times, right?
Yes, ma'am.
2 times you get 42, 0. So what is the HCF of, you see, when they say Euclid's division lemma, you have to write all these steps. You have to properly write all this. So what is this? 504, 735 is equal to, what is the last divisor? 21. So write 21. Calculate HCF of 21 and 84. Understood? Because you already found the HCF of 504 and 735. The HCF is 21. Take that 21 and that 21 and 84. Its HCF is what you need to calculate next. Do the
So
same.
HCF will be the HCF of all the 3 numbers.
Exactly. Yes. So now to divide it, I think it will go directly, right? 4 times. So 4, 8. Yeah, it is direct. So basically, what is HCF of 21 and 84? It is 21.